one of the things you have to know for AP chemistry is going to be polyatomic ions. They're going to show up in equations, and so if you have your polyatomic ions memorized, you can always just keep them together, and it makes predicting products easier. It helps you learn your solubility rules, and just basically it's part of the language. So a polyatomic ion is poly means many, so two or more atoms that are bonded together. They're sharing their electrons, and they're ions because they either have an extra electron or they're missing an electron. So they just arrange the electrons that they do have. They've picked up an electron from somewhere, probably a metal, and so they just share electrons to have a charge. So basically, we're memorizing these names. Focus on the 8s, and now you'll see the pattern from the 8s to the ites. So nitrate is NO3, it has a 1- charge. You do have to know the charge too. And throughout all of your summer review assignment, I use the exact same polyatomic ions over and over and over again, and I hope that helps you memorize them. Carbonate is CO3, it has a 2- charge. Sulfate is SO4, it has a 2- charge. Phosphate is PO4, it has a 3- charge. Acetate can be written as CH3COO, it has a 1- charge. I could write that as C2H3O2 with a 1-. Ammonium's the only positive one we memorized. It's NH4 and it's a 1+. Okay, so if you memorize the 8s, there's a great pattern here. Don't even try to memorize the ones that end in ite because you don't need to. Just focus on the 8s and know that the ite is exactly the same thing as the 8 with 1 less oxygen. So this is NO3 with a 1-. This will be NO2 with a 1-. The charge is the same. There's just 1 electron or 1 oxygen less. So they're going to just share fewer electrons. So then we have sulfate. Sulfite is going to be SO3 with a 2-. So, and then phosphate, PO4 with a 3-. Phosphate, PO3 with a 3-. So the charge is the same. It's just 1 less oxygen going from the 8s to the ites. So we'll see those over and over again throughout the review. So hopefully that helps. You're killing me. Ugh, our smartboard was disconnected, so I might have to do this. Okay, so writing ionic formulas. What happens in ionic formulas is that one thing loses electrons, the metal, something else gains electrons, the non-metal, and you end up with one part being positive, one part being negative. Every electron that is lost by one thing has to be gained by another. So whatever your total positive charge is, that tells you how many electrons were lost by one thing. You need something else to pick up those electrons. So what you do when you write these is you figure out the charge on each thing, and then you make sure the charge is balanced. You use as many sodiums you need to balance out the charge on the chlorides, however you have to do that. To figure out the charge on these things, we just look at a periodic table. These guys all have 1 valence electron. So they're a 1+. These guys all have 2 valence electrons. They lose those 2 negative electrons to become a 2+. Skip the transition metals. They have a variety of charges. You look at what they're bonded to figure out what their charge is. Everything gets 8 electrons in the end. So these guys don't gain or lose electrons. They just stay at 8, so they form a 0 charge. The halogens gain 1 electron to get up to 8, so they have a -1 charge. These guys are going to gain 2 electrons to get up to 8, so they are a -2. And these guys will gain 3 electrons to get up to 8, so they're a -3. So, let's go ahead and make some compounds. First one I had was sodium. Sodium was in that first column. It had 1 valence electron, so sodium is a 1+, Na+. Chloride was a halogen, so it has 7 electrons. It gains 1 more electron. It's a Cl1-. By the way, you'll probably want to stop, pull out a periodic table, and make sure you can figure out the charges of each of these things, and then check yourself to see if you got the right formula. This is already 1+ and 1-, so the charges are balanced as NaCl. Sodium sulfide, we already know this is an Na with a plus. Sulfur has 6 valence electrons, so it gains 2 more. This is going to be a 2-. Okay, so every sodium loses 1 electron. Every sulfide or sulfur takes on 2 electrons. So I'm going to need 2 sodiums to supply the 2 electrons that 1 sulfur needs, Na2S. Magnesium chloride is kind of the opposite deal. Mg is a 2+, Cl chloride is a 1-. So I'm going to need 2 chlorides to take on the 2 electrons that 1 magnesium gives up. So it's MgCl2. Calcium nitride. The calcium is a 2+, the nitride is a 3-. It gains 3 electrons. So if I'm going to transfer the same amount of electrons, 2 and 3 can both go into the number 6. So I'm going to give up 6 electrons on the calcium side by having 3 calciums. 3 times 2 is 6 electrons lost here. Those 6 electrons are going to be taken on by 2 nitrides, because each one can take on 3 electrons. So 2 times 3, 6 electrons gained. Okay, and also you're going to see there's this pattern. For the most part, the 2 goes here, the 3 goes here. You kind of just whoop, swap. Okay, so potassium. I don't like to teach it that way though, because you can just make sense of it and understand electrons are being transferred. Electrons lost has to equal electrons gained. So here's nitrate, NO3 with a 1- charge. There's potassium, it's a 1+. Their charge is already balanced. So I need 1 potassium, K, 1 nitrate, NO3. There we go. Calcium phosphate. Calcium is a 2+. And then phosphate is one of our polyatomic ions as well, PO4, 3-. So we're going to transfer 6 electrons again. Ca, I'm going to need 3 calciums, and I'm going to need 2 phosphates to take on the electrons of the 3 calciums. So again, I did the. All right. So will it work? No, it doesn't. I was hoping. So let's see. We'll look at a few more formulas, more with polyatomic ions. So here we go. I've got sodium carbonate, sodium, Na with a 1+, carbonate is CO3 with a 2-. By the way, I'm going to just go through these really, really fast. If you want to quiz yourself, you could pause, try them out. So I've got sodium carbonate. That's going to be 2 sodiums for 1 carbonate. Potassium is a K+, sulfate is a 2-. Oops, SO4 with a 2-. I'm going to need 2 potassiums for the 1 sulfate. Ammonium is our polyatomic ion NH4 with a plus. Phosphate is PO4 with a 3-. I'm going to need 3 ammoniums to balance out the charge of the 1 phosphate. So NH4 in parentheses, 3 of them, PO4. Okay, that means 3 ammoniums, 1 phosphate. Lead 2, that 2 tells me that this lead is a 2+ charge. It's a transition metal, so we have to tell people what the charge is. Acetate, I can say C2H3O2 with a 1- charge. Okay, I'm going to need 2 acetates for that 1 lead. So Pb, C2H3O2. All in parentheses, I want 2 of these acetates, so I put the acetate in parentheses and put a 2 after. Now I have copper with a 2+ charge, my sulfate, SO4 with a 2- charge. See all this polyatomic ion practice? Their charges are already balanced, so I just need 1 copper and 1 sulfate, CuSO4. This lead has a Pb4+, sulfate, SO4 with a 2-. Okay, so I'm going to need 2 sulfates to take on the charge of the lead. This is pretty much the only time that swapping the charges doesn't work, by the way. Okay, so Pb, SO4 2, 1 lead, 2 sulfates. Now I have ammonium nitrate. Ammonium was NH4. It's got a 1+. Nitrate is NO3. It's a 1-. So their charges are already balanced. Just NH4NO3. Okay, 1 ammonium, 1 nitrate. Manganese 5, that's Mn with a 5+. Carbonate is CO3, it's a 2-. Okay, so I'm going to need 5 carbonates to take on the electrons lost by 2 manganeses. So Mn, 2, and then carbonate, CO3, it's in parentheses, 5 of them. You can see, just swap the charges. All right. I think that might be it on naming. Let's see. Yep, it is.